video, we're going to do a few more naming practice problems. So let's take a look at this molecule over here. This is example letter F. Firstly, recognize it is an alkane because we only have single bonds. So we have to find our parent chain. We could circle this way, and that would leave us with 1, 2, 3, 4, 5, 6 carbons. That looks pretty good, but I don't think that's the longest chain. Let's try this one here. That would lead us with 1, 2, 3, 4, 5, 6, 7 carbons. So that's the better parent chain, the one with the 7 carbons as the continuous carbon chain there. So this is our parent chain over here. And our parent chain we know is a heptane. Heptane, because it's 7 carbons and it's an alkane. Now we're going to circle our substituents. 1, 2, 3 substituents. All methyls, which is nice and easy. We have to figure out where we're numbering from. We can number from two areas, starting from here or starting from here. Let's choose a direction and just kind of experiment and see which one's the best. So 1, 2, 3, 4, 5, 6, 7. If we do that, our substituents are going to be 2, 5. That's right, 2, 4, and 5. 2, 4, and 5. So 2, 4, and 5. If we number the other direction, 1, 2, 3, 4, 5, 6, 7, our substituents would be 3, 4, and 6. So right here, red wins already. So what do we have? We have 2, 4, 5 trimethyl, and then heptane. 2, 4, 5 hyphen trimethyl heptane. That is our molecule name. Let's go to the next one. Our longest parent chain here would not be the 1 carbon chain. It would be this 5 carbon chain over here. We know that's a cyclopentane. Cyclopentane. It's 5 carbons, and it's a ring. Remember, you're supposed to be doing these before you look at the video. So try them yourself, make some mistakes, watch the video, see if you made mistakes, and then correct them and learn from there. That way you will remember what pitfalls to avoid if you actually make those mistakes. That's important. So where do we start numbering? Well, you should really start numbering where the substituent is, because that will give you the lowest number for the substituent. So carbon number 1, right there. So we have 1 methyl cyclopentane. Now, you could also leave out the 1 in this situation here, because there is no other place for the substituent to be other than carbon number 1. If you had more than 1 substituent, you have to leave the numbers because you have to specify exactly where the substituent is. But if I just put methyl cyclopentane, someone would know, oh, that means that there's only 1 methyl group and it's on only 1 of the carbons that has a methyl. That's it. So you could have done that as well. I usually put all the numbers just so I build the habit of putting numbers when I need to. So our next example, as usual, try to pause the video first and then try it, then check. So notice there's a ring, but a ring is not our longest chain this time. This is our longest chain over here. So this time the ring is a substituent and the longest chain is not a ring. It's a linear chain. So for the linear parent chain, we have a butane chain. We have to start counting. If you start counting from the right, 1, 2, 3, 4, you get substituent number 3, carbon number 3. That looks pretty high. I think we could go the other way and get 1, 2, 3, 4. If we do the red direction, we get substituent at carbon number 2. So when you have 3 carbons, that's usually propyl. But since we have a cyclical propyl group, we have to call it cyclopropyl. So this is 2 cyclopropyl propyl butane. And there's your molecule name. We're going to attempt the last three now. So try them yourself. At this point, you're hopefully making fewer mistakes. And if you are making mistakes, they're pretty small. They're small mistakes to make. These ones here are good ones to try because they have some interesting situations that arise here. So here we have our parent chain. You can tell the longest chain is this ring. And so that's a cyclohexane ring, right? Because it's 1, 2, 3, 4, 5, 6 carbons in a ring. Cyclohexane, that we know. Now, here's a tricky part. We can number this 1 methyl to ethyl. Or you could number it 1 ethyl to methyl. It's the same numbering, 1, 2, right? So which one deserves to be 1 and which one deserves to be 2 in a situation where the numbering doesn't make a difference? So where the numbering ends up being the same, what we do is we need to go with a tiebreaker, and that tiebreaker is alphabetical order. So choose the red 1 to make ethyl number 1, and then methyl number 2. So we have 1 ethyl, 2 methyl, cyclohexane. Like that. So normally the priority is to get the lowest possible number at the first point of difference. And alphabetical order doesn't matter too much except for in listing in the name. But if the numbering does not make a difference, then a tiebreaker is required, and that tiebreaker is going to be alphabetical order. So that's a bit of a different situation than you've seen so far. Okay, so next, you can try our next problem here. Looks pretty straightforward. We have our parent chain, which is a cyclohexane. And then you have your methyl groups here, here, and here. And you need to make sure you number so you get the lowest possible numbers. I'm going to try it. So the green direction, 1, 2, 3, 4, 5, 6. So that's going to be a 1, 4, 6. That's one possibility. Let's go this red direction here. 1, 2, 3, 4, 5, 6. So if we go the red direction, that's 1, 3, 4. So already green's out and red is still in. Now I'm going to try one more situation. Let's try this. 1, 2, 3, 4. So I get 1, 2, 4. At the first point of difference, blue wins. So this 1, 2, 3, 4, 5, 6 naming system or numbering, that works best. So we get 1, 2, 4. Try methyl cyclohexane. All right. So now we're going to do our last naming example over here. And then we're going to move on to a video with some drawing. So we have to find our longest parent chain. It could be this. That'd be 1, 2, 3, 4, 5, 6 carbons. Could be this. That'd be 1, 2, 3, 4, 5, 6 carbons as well. 1, 2, 3, 4, 5. Could also be this one here. 1, 2, 3, 4, 5, 6 carbons. So there's a whole bunch of different possibilities that we can go here to make this work out. Generally speaking, if there's different possibilities that can yield different results, you want to go with the one with more substituents. So the one that leads you to having more substituents that are kind of less complicated overall, that's the better approach to take. So if you look over here, suppose I went with this situation here. This one here. You'd only have 1 and 2 substituents. And that's a possibility that could work. But if I went with this one over here, then I'd have 1, 2, 3 substituents. So that's the better option, the one with the more substituents that you have. And you don't have a lot like that, but when you do, just make sure you choose the one with the most substituents. And so we have a hexane. We got to start numbering. So 1, 2, 3, 4, 5, 6. This would make sense, I believe, because you get 2, 3, 4. If you went the other way, you get 1, 2, 3 right away, and that would already be gone, broken. That would already be destroyed. Just because it would have too much, at the first point of difference, it would be a higher number than the direction we chose here. So now we're going to name our substituents, starting alphabetical order here. So we have a 3, 4 diethyl, and then we have a 2 methyl, and then we have 6 in our parent chain, hexane. And that's our final example for naming. You should really try these ones over and over again if you made a lot of mistakes to make sure you understand the concept. And then you can move on to the next video, which will be on drawing rather than naming. So your first order of operation is to make sure you can name from a picture. And then afterwards, when you're done doing that, you can go and try to draw from a name.